Hi Vanguards, I'd like to walk you through the do-it-yourself guide to stoichiometry. It's the first assignment in stoichiometry. And I thought maybe it'd be good just if you want to follow along here if things are kind of weird. So the first thing is stoichiometry is the quantitative study of chemical reaction. We want to know how much reactant we need to begin with, and we want to know how much product we should make. So the steps for most stoichiometry calculations include write the reaction like we've done many times, including the correct formulas like sodium sulfate is Na plus 1, SO4 minus 2, crisscross applesauce, Na2SO4. And then once we're done with that and we know that it's Na2SO4 and we're not going to change any of those subscripts, then we balance it by using those coefficients in front of the numbers. And then underneath each species in the reaction, we're going to write the grams per mole, which is also known as molar mass, M-O-L-A-R, mass. We're going to write down the grams of substance, and we're going to write down the moles. And so moles and grams, we haven't done that for a while, but we're going to put everything together right now, and so we'll need to revisit the grams and the moles thing. We want to calculate as much information as is possible using this equation quite regularly. Now this moles equals grams divided by molar mass, that equation, a simple way to do that is using a little calculator like this. And if you write down moles, M-O-L, this is a shortcut, equals grams over molar mass, right here, mm, you have an equation that you can use to calculate anything you want. For example, if you want to calculate grams, and you know the moles and you know the molar mass of something, you cover up grams, that's what you want to get, and then you're left with moles across from molar mass, and so you multiply those two. Let's say that you know the grams and the molar mass and you want to calculate the moles. You cover up the moles and you have grams divided by molar mass. Once in a while you'll have to calculate the molar mass, so you cover up molar mass and you're left with the equation being grams divided by moles equals molar mass. So this is kind of a shortcut way to do the molar mass thing. And we're also going to be using the molar ratios. So I kept on saying in those last videos, I kept on saying, well, we have a 2 to 3 to 5 to 7 mole to mole ratio. And I did that for a reason, because we're going to start using that right now. So let's take a look at this first problem. All right, I'm sorry, let's take a look at the first example. We can decompose potassium chlorate. So decomposition, one thing becomes 2 or 3 or 4 smaller things. And it's potassium chlorate, so potassium is a K and chlorate is a ClO3 negative 1. So K, let me look, it's a plus 1. Chlorate's a minus 1, so we need one of each. Potassium chlorate. It decomposes into, now this is a little bit hard for you to know, so I gave it to you. It decomposes into potassium chloride and oxygen. Actually, this is similar to what we used in the fume hood when I burned up that pencil, remember? That was actually sodium chlorate, and that decomposed into sodium chloride and oxygen gas. All right, so we're just going to look at potassium chlorate decomposing here. Well, all right, K is a plus 1, Cl is a minus 1, oxygen all by itself, so that gets an O2. Okay, we are done with the skeleton reaction. Done with the skeleton reaction, let's balance it. 1K, 1K, 1Cl, 1Cl, 3 O's, 2, uh-oh, sets of 3, sets of 2. I need 2 sets of 3 and 3 sets of 2. I think I just messed up my K's and Cl's, so I need a 2 here. We have a 2 to 2 to 3 mole to mole to mole ratio, and ratios work forward, they work backwards. We could also say we have a 3 to 2 to 2 mole to mole to mole ratio, or if we're only concerned with these two columns here, we could say, oh, we have a 2 to 3 ratio or a 3 to 2 ratio, depending on which direction we want to go with this. Okay, so we have a balanced reaction. It's a 2 to 2 to 3 mole to mole to mole ratio. The question says, now there's going to be lots of opportunities in here to take shortcuts and say, like, because I might ask you, hey, tell me everything about this and tell me everything about this, but you don't have to tell me about this. So there'll be various different ways that questions are asked. In this case, it says we started with 2.5 grams of potassium chlorate. So probably we're going to need that 2.5 somewhere. It says 2.5 grams of potassium chlorate. Where would that? Oh, that would go right here. 2.5 grams potassium chlorate. Write that down, please. How many grams of KCl and how many grams of oxygen would we make? Okay, I am asking you for everything here. So we want to get this and we want to get that, the grams of each one of those two. Well, we know we have a 2 to 2 to 3 mole to mole ratio. So if I can figure out the moles here, I know I'm going to have the same number of moles of the second one and 1.5 times as many moles of that. So let me figure out the moles of this. Well, let's see. According to our little calculator, moles equals grams divided by molar mass. All right. I've got the grams, so I'm going to put a little check mark there. Grams, got it. Molar mass is pretty easy. It's KClO3. Do not use the 2 for molar mass. Remember that. We did that before. It turns out that the molar, did I do that already? 122.5 grams per mole is the molar mass of KClO3. I mean, it's getting kind of messy, so I'll clear that up. Okay, so 122.5 grams per mole of KClO3. 122.5 grams. Got that from the periodic table. Potassium weighs 40, Cl weighs 35, O weighs 16, there's 3 of them. Don't use the 2, don't use the coefficient for this. So when we calculate the moles, moles equals grams divided by molar mass. Of course I didn't grab a calculator. Let me calculate the moles. Moles equals grams divided by molar mass. Grams, 2.5, ooh, this is going to be a small number, divided by 122.5, boom. We've got 0.020 moles. 0.020, because looks to me like we're using 2 sig figs. 0.020 moles, all right? It's a 2 to 2 ratio right here, so how many moles goes here? 2 is to 2, as 0.02 is to 0.02. Same number. Now, 2 is to 3, as 0.02 is to 0.03. If I didn't know that, I could set up a ratio like 0.02 is to x as 2 is to 3, cross multiply and you get 0.03. Alright, so now the question said how many grams of KCl? How do we calculate the grams? Cover up grams and we have moles times molar mass. And the molar mass of KCl, don't use the 2, is 39 plus 35 is 74, I guess. I think 74 grams per mole. And I want to calculate the grams, moles times molar mass. 0.02 times 74 equals, I think it says 1.5 grams. How many grams of oxygen? All right, we know we have 0.03 moles. The molar mass is 16 plus 16. Don't use the 3 for molar mass. It's 32 grams per mole. My calculation is moles times molar mass, so 0.03 times 32 equals 0.96. 0.96. So there are the two answers, 1.5 grams and 0.96. Well, let's double check it. In a chemical reaction, mass is not created or destroyed. We better have the same amount of mass on this side as on this side. Well, this side we had 2.5 grams. This side we had 1.5 plus 0.96. Well, if you round it off, round this to 1, that gives us 2.5. So rounding did give us a little bit of a problem. Now remember, mass is not created or destroyed, but that does not apply to moles. Let's go and do another problem down here, the next problem. Okay, 7 grams of hydrogen gas and some amount of oxygen gas react to form water. All right, skeleton reaction. Hydrogen gas all by itself, H2. Oxygen is O2. Water, you can write it as H-OH or H2O. And the balanced reaction is, I'll just balance it right here. In my red pen, 2 H's, 2 H's, 2 O's, 1 O. I need a 2 here. I need a 2 there. It's a 2 to 1 to 2 mole to mole to mole ratio. So that's balanced. Well, let's see. 7 the question says 7 grams of hydrogen gas. Where does that go? 7.0 grams, 2 sig figs. Some amount of oxygen gas react to form water. Calculate all variables. So I've got to get everything in here figured out. All right, I can do that. Grams per mole is easy. Just use the periodic table. H2, don't use the 2. So that's 1 plus 1 is 2. I'm a genius. Oxygen gas is 16 plus 16 is 32. Water is H2O, so 1 plus 16 is 18 grams per mole. And I've got 3 out of the 9 done already, a third of my points already. So now, I can't calculate this because I need, if I have 3 variables, moles, grams, molar, mass. If I have 3 variables, I need to know 2 of them before I can calculate that. So, can I calculate this? No. Can I calculate this? No. Can I calculate this? I've got 2 things. Yes, I can. 232.18. 232.18. 232.18. Okay, let's go. Okay, 7 grams of hydrogen gas, 7.0. Moles equals grams divided by molar mass. Grams, 2 grams. Yep, nope, 7 grams. 7 divided by molar mass is 2. 7 divided by 2 is 3.5 moles. Well, we have a 2 to 1 ratio. Well, I could calculate this like 2 is to 1 as 3.5 is to x. Cross multiply, solve it. But I can also do this in my head, I think. Because 2 is to 1, that's half as much. So what's half of 3.5? Well, half of 3 is 1.5, so 1.75. 1.75 moles. And then 2 is to 2, or we could say 1, these ratios, you can use any ratios that you want to here. Whichever ones make your life simplest. For me right now, 2 to 2, that's so easy, it's exactly the same. 2 is to 2 as 3.5 moles is to 3.5 moles. Bang! Got it. All right, we're supposed to calculate the grams. Calculate the grams. Cover up grams, moles times molar mass. 32 times 1.75, 32 times 1.75 equals 56. 18 times 3.5, 18 times 3.5 equals 63 grams. Well, did I do it right? In a chemical reaction, mass is not created or destroyed. So, the grams, the mass on this side, had better equal the grams on this side of the arrow. 56 plus 7 is 63. Oh, this side we have 63 too. Nailed it. Should we do another one? Oops. Edit. Clear, ink from page. Guided problem here. How many grams of C2H4 and O2 are required to make 36 moles of water? Sounds like a combustion reaction to me. Skeleton reaction. Dicarbon tetrahydride. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Dicarbon. C2 tetrahydride. H4 plus oxygen all by itself is 2. Makes carbon dioxide, CO2, plus water, H2O. All right, let's balance it. 2 carbons, I need 2 carbons. 4 hydrogens, I need 4 hydrogens, so 2 goes there. 2 sets of 2 is 4 oxygens, 2 sets of 1 is 2, 4 plus 2 is 6, so I need a 3 here. We have a 1 to 3 to 2 to 2 mole to mole to mole ratio. And so now all you need to do is, down here, make a little line, line, line. Try to make them all nice and parallel with one another. If you're neat on this, it helps a lot, which is one of my biggest downfalls. I have a lot of downfalls, but being neat is among my worst things. All right. The question says, let's see if we can take a shortcut here, or not do all the work. How many grams of C2H4 and O2? All right. So the only thing that I have to calculate for sure, I need to get that answer and that answer. All right. Well, I'm thinking moles, grams, molar mass. If I need to get the grams of this and the grams of this, I need to know moles and molar mass. Molar mass I can do right off the bat. C2H4 is 12 plus 12 plus 1 plus 1 plus 1 plus 1, so 24 plus, that's 28 grams per mole is the molar mass. Oxygen, don't use the coefficient, so it's just O2. 16 plus 16 is 32. I don't think I need to do anything in this CO2 column. Nothing. So I could just skip that. I wish. But it does say, so my clue, the thing that I can tap into here to do my calculations are this. I want to make 36 moles of water. 36 moles, so this first line is molar mass, the second line is moles, the third line is grams all the way across, and it says 36 moles of water. 36 moles. Well, we have a 1 to 3 to 2 to 2 mole to mole ratio. Let's go, let me get a different color pen, nice and green. So let's figure out the moles here and the moles here. Well, I've got a 2 to 3 ratio right there. 2 to 3. So 1.5 times as much. 2 is to 3 as 36 is to, let's see, 36 plus 18, 56, 54 I think, right? 54 moles. And then I can either go 3 to 1 is the same as 54 to something. That's not that familiar numbers. So I think I'll do this. 2 to 1. 2 is to 1, that's half as much, as 36 is to how much? 18. Alright, I can do both of these equations easily now because I need to know 2 of these 3 variables before I can calculate the third one. So I want to get grams, cover it up grams, it's moles times molar mass. So all you need to do is take 18, which is the moles, times the molar mass, which is 28, and whatever that is, there's your answer in grams. The same thing for this one. Grams equals moles times molar mass, 54 times 32, get your answer. Now the only thing I'm feeling kind of guilty about is that I have trouble checking my answer right now. The check on these things is, in a chemical reaction, mass is not created or destroyed. And I have the grams here and I have the grams there, if I did my math, if I weren't so darn lazy. But over here I don't have the grams. And so I don't really have a good check on this. So that's could be a problem. Let's go to the next page. All right, number 1, calcium and water combine to form calcium hydroxide and hydrogen gas. Calcium, Ca, just Ca, it's not one of the lucky 7 or anything. Calcium, and that's a plus, water, H. Now I did see hydroxide over here, so I'm going to write water as HOH. You can write it as H2O if you want to, but I think my way is going to be a little bit easier to balance here in a minute. To form calcium hydroxide, to form, that's an arrow, calcium hydroxide, CaOH, periodic table says calcium gets a plus 2. Hydroxide is, for my flashcards, and -1, plus 2, -1. I need 2 of those. And plus hydrogen gas, H, all by itself, H2. Now I should be writing down the form of these: solid, liquid, aqueous, gas. But I don't think we need to really worry about that right now for this equation. I shouldn't be lazy, but you know me, kind of am. So we need to balance this. We do need to balance it every time. 1 calcium, 1 calcium, 1 hydrogen here, makes those 2 there, so I need a 2. 2 OHs, 2 OHs, done. We have a 1 to 2 to 1 to 1 mole to mole to mole to mole ratio. Now I need line, 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 right underneath this. Oops. And line, 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 and line, line, line. The labels for these, I guess I should be consistent, but I'm usually not. I know I need grams, I know I need moles, and I know I need molar mass. So it doesn't matter, but here in the previous page we were using molar mass, grams, and then moles. Molar mass, which is grams per mole. Grams was the second one. Grams and moles goes here then. You can put these, it doesn't matter the order that you put these in. Okay, Let's figure out what the question is asking for and figure out what our handle is on how to do this. We want to form 23.5 grams of calcium hydroxide. 23.5 grams, all right? 23.5, that's what I'm aiming at, 23.5 grams, because of how much hydrogen will also be made. Okay, so the first question says, hey, just how much hydrogen? So we have to figure out how much that means grams. How many grams of hydrogen will we make at the same time? Erase that so it's neater. How many grams of calcium, how much water? Oh, you know what? We have to do everything in this. What a mean person made this question. We have to calculate every one of these, 3, 6, 9, all 12 of them. All right, we can do that. Molar mass is super easy. Calcium weighs 40, look at your periodic table, 40.0 something. Water is 18, we've done it a million times. Calcium hydroxide, so that's 17 plus 17 is 34, plus 40 is 74 grams per mole. Hydrogen is 1 plus 1, even I can do that, it's 2. We don't have any other information. Which one of these problems can we do using our moles, grams, molar mass calculator? We have to do whichever set of 3 has 2 variables given to us, and obviously that's this one. So we can calculate the moles, all right? Cover up moles, grams divided by molar mass. Grams here, molar mass, the units are grams per mole. Let's go! 23.5 divided by 74, it's about a third, right? 23.5 divided by 74, bingo, 0.32. 2 sig figs. Let me put this in a different color, magenta, 0.32. Well, all right, let's figure out the moles of all of these. It's a 1 to 2 to 1 to 1 mole-to-mole ratio. Well, let's see, 1 is to 1 as the 0.32 is to 0.32. 1 is to 2, ooh, twice as much. What's twice as much as 0.32? 0.64. Now, we can either go 2 is to 1 and have that, or if we're lazy, like me, you can say, well, 1 is to 1 as 0.32 is to 0.32. Now it's duck soup. Calculate the grams and the grams and the grams. Grams equals moles times molar mass. 40 times 0.32. 18 times 0.64. That gives you the answer here. 2 times 0.32 gives you the answer here. Now make sure that you double check your answer by looking at the grams. Grams on the left side of the equation should equal the grams on the right side of the equation. Let's do another one. Whoops, too far. How many grams of calcium hydroxide will react with phosphoric acid to form 5 grams of calcium phosphate? Ooh, hey, this is a good one. How many grams of CaOH2 will react with phosphoric acid H3PO4? It's on the flashcards to form, uh-oh, I didn't give myself enough space here.